Hi everyone and welcome back. So today we're going to look at 5.3. This is misleading graphs and statistics. Go ahead and write your name, class hour, and today's date for me up at the top. And let's take a look. Okay, go ahead and pause and do the bell ringer by yourself. And when you're ready, then we'll catch up and we'll go over it. All right, let's take a look. We're going to look at hockey. So right now it's January as I'm recording this, so we are definitely in the middle of hockey season. Let's see. So it says the Stanley Cup is awarded annually to the champion team in the National Hockey League. The graph shows the total number of points scored in Stanley Cup playoff games by 3 players during their careers. Number 1, according to the size of the players, how many times more points does Messier appear to have than Curry? All right, well, if you look at Curry and then you look at Messier, it looks like it's about double the size, so about 2 times as many. Let's see, I'll just do it that way. I'll keep going. There we go. All right, number 2. Do you think this is representative of the player's number of points, and explain? So just looking at it, does it look representative that he really had twice as many? And the answer is no. Okay, so no. The graph is misleading. It only looks like Curry had half the points of Messier. It looks like Curry had half the points of Messier. I guess that's how you say it. It's exactly like it looks. Okay, and then number 3. What reason could someone have for intentionally creating a misleading Stanley Cup graph? Okay, so think about it. Why would someone create a graph like this? So they either want someone to look like they have way more or way less, right? So someone might want the point total for Gretzky to appear greater than it actually is. Okay. All right, so there's that. Okay, let's take a look at the objectives for today. So based on just exactly what it says, we're going to determine whether statistics are misleading and when graphs are misleading. Recognize when statistics are misleading. And then we're going to recognize when graphs are misleading. All right, let's go ahead and move on. So pause it real quick if you need to. All right, let's take a look. We're going to explain how the graph's different. So we have spring dance tickets. We have graph A and graph B. They do both show the same exact data. However, one looks a little more greater or less, however you want to look at it, than the other. All right, so we need to explain how they differ. All right, so what's the differences in the two? Well, the years are the same, the title's the same, but the scale is different. Okay, so graph B uses a smaller scale. All right, and then we'll add a little bit more to this. So this makes the price look like it increases more rapidly. Even though it doesn't. It increases the same. Okay. So why would we want to do different graphs? Well, it basically depends on how you want to put a spin on it. All right, if you're trying to show that prices really haven't gone up very much, then you would use graph A. But if you want to show that prices have gone up a lot, then you would use graph B. Okay, now do they technically all show the same thing? Yes, they do. All right, but just looking at it far away, it's like, oh, well, on the left side in graph A, the tickets have just barely gone up. Whereas over there, it's like, oh, they go up a whole lot every year. Okay, whereas 06, 07, they were the same, and then from there it's been about a $2 increase ever since. All right, so depending on which way you need to sell it, then that's which way you would go with it. All right, and people do this in marketing all the time. All right, they try to tell their bosses one thing, like sales are through the roof. Well, sometimes not. All right, sometimes those graphs are misleading, and we're going to take a look at one right now. All right, let's go ahead and move down to the bottom. All right, it says the line graphs show monthly profits of a company from October to March. Which graph suggests that the business is extremely profitable? Which is a valid is this a valid conclusion? And explain. All right, so let's take a look here. We have the first graph and the second graph. So which one looks like it would be extremely profitable? In this case, that would be graph A. All right, I'm gonna go ahead and scoot down just a little bit more so I got more room right here. We just gotta have the graphs. We know what all the rest of it says. Okay, so graph A. We'll call this A and this one B. Okay, so graph A shows the business extremely profitable. Okay, and then why is this? Okay, we'll take a look. All right, so how come that one looks so much different than B? Because they always show the same data, right? They're not saying that the data is wrong, but what's different about it? Okay, take a look. I mean, they do both start at 0. So you probably noticed that over there on graph A, we start out by counting by 500s, and then all of a sudden we start counting by 100s. Whereas over on graph B, we continually count by every $500, right? Okay, and we can't just skip around all over the place. Okay, we know that from science class with our graphing in there. All right, so this is because graph A does not use a constant scale. Okay, so is this a valid conclusion? So no. That makes it invalid. All right, we know from graphing that you have to use the same scale all the time. If you want to count by 100s, that's fine, but you're going to have to do it all the way. All right, so if they really wanted to make themselves look good, they would have started at 4,000 and just kept going up by $100 every single time. Because look, from October to March, all they basically made was $1,400. Okay, now I don't know what company this is about, but I'm pretty sure that if my company was only making $1,400 for about a 6-month period here, I wouldn't be too happy, all right, because that's not even paying the light bills, right? All right, so you have to find the happy medium in there. All right, now I understand that they probably did this way because the graphing got hard, because if you kind of look on graph B here, there's some dots that's not exactly at the intersections of the coordinates, which that happens a lot, so you're going to have to, pick your own poison here. All right, let's go ahead and take a look then at the next one. Okay, example 2 says, an amusement park boasts that the average height of their roller coasters is 170 feet. Explain how this might be misleading. All right, let me go ahead and roll down here. I don't know why I made this chart so huge. Probably could have saved a little bit of paper there, but that's okay. Okay, so they're saying that the average height is 170 feet. So let's figure out if that's actually true. So let's figure this out. Okay, so let's add up all of our numbers here. So grab your calculator, pause if you don't have one, go ahead and get one real quick. All right, let's add these up. So we have 109 plus 135 plus 115 plus 365 plus 126. And I came up with 850. Okay, let's divide that by how many there are. So divide that by 5. And I come out to 170 feet, so they're not lying. So they're saying that the average height of the roller coasters are 170 feet. So why is this misleading then? Are most of the roller coasters 170 feet? Because I don't see it. The Viper's 109, that's nowhere near 170. 135, that's closer, but still not even close to 170. 115 is definitely not closer. 365 is way over, and 126 is not. So there's not even a single one even close to 170. So how can they possibly say that? Well, they didn't lie because it is true. All right. What happened is they actually used the true mean. What they should have used was a different measure of center. Okay, so what are our measures of center? We just talked about these. It's the mean, the median, and the mode. All right. Well, would they use the mode? No, because there's not even a mode, so they wouldn't say that. Okay, so they couldn't even say that most of our roller coasters are da 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 da. All right, they can't even say that. So what they'd have to actually say is what the median is. So let's figure out what the median actually is. So let's sort these from least to greatest. So we would have 109, 115, 126, 135, and 365. Okay, so the median is the middle one. Okay, are they somewhere close at least to 126? Yeah, that's a little bit better than 170. Is any of them 126? Just one of them, but at least they're not that far off. I mean, when we're talking about feet, you're talking about 10, 11 feet here. Okay, a difference here. It's not that much. All right, so that's actually a better one. All right, so even though they used the average height, they should have used the median. So that's what we're going to write as our little thing here. So they used the mean and they should have used the median. Okay? And companies do this all the time. They'll say, well, our average price is blah, 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 blah. Well, it may be, but whenever you get down there, it's because they took the highest one, which is like $9,000, and they put it with the $2 something or other, the $2 broken lamp that someone gave them, and there you go. All right. So yeah, their average may have only been, whatever, $1,000, but really it's 9,000 because you had everything was $9,000 plus, and then you have the one item that's like $2. All right. All right, let's check out the last one here. All right, it says to actually find the mean, median, and mode of the sofa prices shown in the table, which measurement would be misleading in describing the average cost of a sofa. All right, so that's what I was just talking about. Okay, so let's take a look here. So we're supposed to find the mean, so let's do that. So let's add up all of our numbers. Okay, so that's 1,700 plus 1,400 plus 350 plus 1,600 plus, oops, there should be a plus there, plus, and then 1,400. We're going to divide all that by how many there are. There's 1, 2, 3, 4, 5. We're going to divide all that by 5. Okay, so go ahead and do that. So we're going to take 1,700 plus 1,400 plus 350 plus 1,600 plus 1,400. And we should have came out to 6,450. Okay, we're going to divide that by 5. Okay, so go ahead and do that. So 6,450 divided by 5. 6,450 divided by 5. And that comes out to $1,290. Okay, so let's just stop and take a look real quick. Are most of them around $1,290? No, most of them are much more than that, right? Okay, then you got the DIY, which is only $350. All right, so now we're going to find the median. Okay, so remember, when you find the median, you got to sort them from least to greatest. Okay, so the lowest one's $350. Then you have 1,400. You got 1,400 again. Then you have a $1,600 one. And finally, we have the $1,700 one. All right, so the median is the exact middle. So which number is exactly in the middle? That's our 1,400. Okay. So does 1,400 describe most of them? I'd say yeah. I mean, you got 2 of them that are higher, but 2 of them are exactly that, so you're not lying. All right, and of course the 350 one's that outlier I was talking about earlier, just throws the whole thing off, so we wouldn't use that. Okay, or could we use the mode? Okay, the mode is one that occurs most often. Well, the mode would be 1,400. All right, so what they're asking us is which measurement might be misleading in describing the average cost. Okay, so which one is actually the most misleading? Well, they would want to use the mean, right? Because the mode and the median both tell it exactly. So we're going to say the mean would be misleading. Most of the sofas are more than that. Most sofas cost more than, let's I guess be specific here, what was our number? $1,290. There we go. All right. All right, and again, people who are in business, they know this and they do this all the time. Okay, they can type in their numbers really quick and they can quickly find the mean, median, mode of all their merchandise. And whenever it's advertisement time, they can just spit something out at you and you're like, oh, that's great. And then you show up and then you're like, wait a minute, this isn't what they said. All right, and that's because they didn't lie, technically. Whatever they told you is technically true. It's just they didn't use the right one, okay? The mode would probably be more better sometimes, or the median, okay? The mean is not always the best, okay? We always think that the mean is the true average, and it is the true average. However, it's just the average of the data, not necessarily of the number of the numbers. Okay, because you get one outlier in there and it's going to throw everything off. Okay, that's what I was talking about with test scores that time. You have one person who doesn't take that test for me, all right, and then when I go type all those numbers in to turn into the State Department, it throws the whole thing off because it makes my class look like they're doing horrible percentage-wise. Well, it's because one person didn't take it. So if I took them out, that means that 0 would come out. Well, then everyone would shift way higher. Okay? So, and how that works is if one person gets a 0 and one person gets 100, when I take the average of the two, it says that both of them got 50%. Well, they both didn't fail. Okay, it was just the opposite. One person got 100 and the other person didn't take it at all. So there you go. All right, that's it for this lesson. Thanks for watching, and subscribe if you haven't already, and give me a thumbs up, and I'll see you next time. Bye.